Hello everyone, it's me again, Widi. Okay, today we are going to analyze quartiles and how to spot outliers. And today we are going to use the data of Labubu sales in Sydney on 2024. Okay, to identify outlier, we have to start with understanding the quartiles. Okay, so if we already understand the quartiles, we will be able to spot which data is included as outliers. And in this video, I will also explain how to calculate quartiles and outliers. And there will be three methods to spot outliers. And the last one is the easiest one and the quickest one. Yeah. So what are quartiles? Okay. So quartiles divide a sorted dataset or ranked dataset into four equal parts. Okay, so these are the equal part. So for example, Q0, which is the smallest, it indicates the minimum value of the data, and the Q2 is the median, and Q4 is the maximum. So for Q1 and Q3, Q1 is considered the first quartile. 25% of the data smaller or fall below this value, and for Q3, 75% of the data falls below or smaller than this value. So here is how you can understand more by using the real sorted data. Okay, let's say we have sorted data from number 1 to number 9. Okay. So the smallest data is Q0, and the largest data is Q4 or maximum value. So we divide it from the maximum to minimum into two, and in the middle we will have Q2 or the median, and and from Q0 to Q1 we take the middle one, which is 3. This one is Q1, where 25% of the data is smaller than Q1, and Q3 is between Q2 and Q4, and in Q3 75% of the data is smaller than Q3. Okay, so we will be understanding more when we are using the real data in Excel. Okay, before we go any further, now we have to understand a little bit about what is the difference between average and median. I believe you already know the difference, but the thing is that oftentimes median is a better measurement than average. Okay, here is why. Okay, let's say there is a group of 10 entrepreneurs in this room, and their average wealth is 100 billion Australian dollar. So the minimum is 700 billion, and the maximum, the richest one, is 200 billion. Okay, so their average is 100 billion, let's say, and their median is also 1 billion as well. Okay, let's say a rich entrepreneur join this group. Elon Musk, oh sorry, not this one, I mean Elon Musk. Okay, so Elon Musk joined the group, and his wealth is 100 billion. It's like 100 times of the 10 entrepreneurs average. This will change the average. Okay, so the average would be 10 entrepreneurs times 1 billion, which is 10, plus 1%, that is Elon Musk, is 100 billion, divided by the number of people, which is now 11. So we get average of 10 billion for the wealth. Yeah. So what I'm trying to say in here is that the wealth of the 10% in the group stays the same. Yeah, they just their wealth is just from 700 million to 2 billion. It doesn't change. They 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 are not getting any richer. But however, because someone that is very rich joined the group, the average become 10 billion, 10 times more wealthier than before, even though the money they own is actually stays the same. Yeah? However, the median of the data, yeah, should be quite similar still around 1 billion. Yeah. So in this case, that's why sometimes the median is a better measurement than the average, because yeah, in median, even though there is a very rich person join the group, the median doesn't really change that much. Yeah. So Elon Musk, in this case, is considered an outlier because his wealth is very different from the rest. So what are outliers? Okay, in the previous page, we know that Elon Musk is an outlier. Okay, so what are outliers? Outliers are a data point that's significantly different from the majority of the data. Okay, how to spot this? How to spot this? First, you have to sort the data in the ascending order, let's say from the smallest to the largest. And then we determine Q1, Q2, and Q3. After we know the Q1 and Q3, we can calculate the IQR or interquartile range. How to do so? So you just need to subtract the value of Q3 minus Q1.
Okay, from the previous slide, we already know that one of way of identifying outliers is using the IQR. Now I will explain three different methods, which is basically only two. Okay, the first method is using ZScore. ZScore is how far a data point from the average of your data set, and it is divided by standard deviation. So it is measured in units of standard deviation. So the formula looks like this. Z-score equals the data itself subtracted by the mean and divided by the standard deviation. So when would you say that it is outlier? Whenever the absolute value of the Z-score is larger than 3, or in other words, if you divide it into positive and negative value, the positive Z-score should be above 3, then it is outlier, or the negative score of the Z-score should be less than negative 3. So basically, if you are confident enough that the data is normally distributed, you can use Z-score right away. And the more robust method is the IQR method. So as already explained previously, to know that the lower bound is Q1, the quartile 1, minus 1.5 times IQR. What is IQR? IQR is basically Q3 minus Q1, yeah, multiplied by 1.5. So you subtract this value to from Q1, and the upper bound is Q3 plus 1.5 IQR. So what is outlier? Outlier is any data outside the range between lower bound until upper bound. And the last method is much faster. Basically, it is the same, the IQR method, but using Excel BoxPlot or Box and Whisker, it will be faster. The next video will explain how to use method 1, method 2, and method 3 on the separate video. Thanks for your time. See you again next time.